So hello everyone. Today in this video we are going to solve lead code problem of the day, that is total waviness of numbers in range 1. So let's first read the problem. You are given two integers nums1 and nums2 representing an inclusive range. The waviness of a number is defined as the total count of its peaks and valleys. So a digit is a peak if it is strictly greater than both of its immediate neighbors, and a digit is valley if it is strictly less than both of its neighbors. The first and the last digits of the number cannot be peak or valley. Okay, any number with a fewer than 3 digits has a waviness of 0. So return the total sum of waviness for all numbers in the range num1 to num2 inclusive, right? So basically, what is the question? So here we need to find the waviness of a number. Now waviness of a number is like, see, if you are given a number, so in a number you want to means loop through the digits, you want to go through the digits, right? And you need to check whether the digit is strictly greater than its immediate neighbor or strictly less than its immediate neighbor. If this is the case, then you say that means there is a waviness, right? Means you are like incrementing your counter if you encounter such a number, right? So here you can see that between 120 to 130, so what is a means total waviness for all the numbers in this particular range. So 120, so you can see that, see, you always have to exclude this 1 and 0, means extreme element, first and last element, you always exclude it. You will only consider the between elements, middle elements, right? So here you can see the 2. Now 2 is greater than both of its immediate neighbor, right? So I will say 1 waviness, right? Then 121, so again 2 is greater, so 121. Now if you see 122, see, so if you take a 2, then exactly to the right of 2 means immediate right of the 2 is 2, and 2 is not strictly great, means they have told that you have to consider strictly greater. So 2 is not greater than 2, right? So you cannot take it. So that is why when you write all the numbers between 120 to 130, you would find that the total number of the waviness of this particular range is 3, right? And finally you can see that 130, so 3 is greater than 1 and 0, and that's why they have increased 1. So thus the total waviness is total 3, right? So I hope this question is now clear. So we can now move to the solutions. So how can we solve it? So first we will look at a constraint. So constraints is like pretty small, means 10 to 5. So you can apply the brute force approach and it would work, right? Fine. So I have means solved this problem using a brute force only, and I'll walk through my code now. So here I will start from nums1 to nums2, and what I am doing is I am converting the number into string, right? So that it becomes easier to traverse. And I'll start my means j from 1 because we want to exclude the first and last element, and that's why here also I have written that nums of size -1, so it will not consider the last number, right? Last digit, sorry. And finally I'll check that whether this particular element is strictly greater or strictly less, accordingly increment the counter, and then finally simple return it. So let's run the code. Yeah, it's working, and let's submit it. Okay, so it got accepted. So the time complexity of this particular problem is big O of n, because see, numbers of digits are like 5, so this inner loop will at max will run means 5 times, right? So I can ignore this, you can consider this as a constant, right? So your time complexity is big O of n, right, for now. And your space complexity is like also big O is constant because you are not using any extra spaces. So I would say like time complexity of this particular problem is big O of n, and space complexity is big O of 1, right? So I hope you understood this problem and how can we solve it. If you have any doubt, you can ask me in the comment section, and if you are new to my channel, I would encourage you to subscribe it. If you really enjoy this video, then like it, hit the bell icon, and Yeah, thank you.